Hi everyone, welcome again to my YouTube channel Fitness Pitch Community Geek. In the last lecture, we have seen multiplication code, and that was the end of our coding on loops. So we have seen multi-level loops, how the loops work, and we have seen some lots of code example there. So hope the concept of loops are now clear to you now. So in this lecture, I will be introducing the most important topic of C programming, that is pointers. You'll heard about telling me a lot of time about pointers, what is pointers and why it is essential in any programming language. First of all, it will take 10 to 11 lecture to complete the pointers. I guess hope it is possible more earlier. But I will be going through all the concepts from basic to depth of this topic pointers. So it is very important and very crucial for in any further cases like and designing data structure like linked list and trees. It will be helpful if you know the idea of pointers. And pointers are very powerful tool, you can say, for C and C++ programming especially. They're very powerful tools. You can make your computer collapse by using that pointers. That much powerful. So in this topic today's lecture, I will be just give you an introduction of pointers and just the naive terms and what is pointer, and I will from next lecture I will go through the technical terminologies. Okay, so I will just go through why we are studying this pointer and what is the motivation behind this. So we'll see this in this lecture. Okay, so without any further ado, let me go into my PowerPoint slides and let me show you guys what I am talking about. So first of all, what is a what is pointer actually? So you can see a thumb, a index finger is pointing to something. So this is the basic idea of pointing. It's point to something. Something points something are known as pointers actually. In naive term, you can understand that something which point to something known as pointers. This is pointers. So what is a pointer actually? So you can see that the thumb and the index finger is pointing somewhere in right wise. So this is the basic idea behind the pointers. So you're gonna see that this will be very interesting topic. This is actually a very interesting topic. There are a lot of things to understand and learn in this topic. And it is, and at the same time it is quite fascinating also. Fascinating also. So before going into depth of pointer, now let me go into the or you can say go some back in times with reference to lecture. Let me go back in time and remind you about my arrays lecture where I have told you how the actual memory work. Actually it is part of operating system, but somehow I have given you some detail about how the memory work actually. How whatever you write in computer. Suppose let me give you example. Suppose you write something like suppose this is your process. This is your process and you write something. Process means what? You actually imagine it's something else, like you write your C program like example like example.c. You can write something and you write your code here. So what is happening actually is our computer, that is the machine. So suppose this is the memory. Suppose this is the code, you write something here. So how your computer how your computer actually deal with this. This is the machine and this is just the hardware design. Main task is done in the CPU of it. Okay, this just for your friendly purpose. So how this code is stored? Code is stored in the CPU. Means what was I talking about, that you write something here. So how this actually is stored in the CPU? This is the question. Actually being stored in CPU. Okay, this bits of binary is actually being stored in our computer. Okay, so this is, you can see this is binary bits. So how these bits in form of 0 1 1 0 something, in form of 1 1 0 0 something, how it's actually being stored. So computer is only work, its brain only work on binary 0 and 1 only. So we have to deal with, we already know this part, that we have to deal with zeros and ones only. Whatever we write in our skin in English language or any language is actually at the end of machine code, it is converted into this binary form. So how we deal with this actually? So how this bit actually is stored? You can see there are trillions and trillions of bit actually. These days the memory come in TVs. So one TV is 10 to the power 40, so it can actually store the bits in TV. So today the memory come in TVs terabyte, so we can store 10 to the 40 bits actually. terabits means. So GBs mean 10 to the power 40. You already know this pass actually, I guess. So GBs mean 10 to the power 30. Like imagine that process here is your 1 GB actually. So your process is suppose 1 GB. So it will have 110 to the power 30, 2 to the power 30 bits actually, not 10 to the power 40, 2 to the power 40. Okay, 2 to the power 40 bits. It's all because we are dealing with binary. So it will have 2 to the power 30 bits. So how these bits are been organized and how these bits are actually stored in memory, it's not like random something. It is done in with some sequence, and so we will now see how this actually being stored. So now let me give you some brief idea. You will, if you have more interest, you can read in it and operating system memory management part, but I just want to teach you pointers. So I'm going to tell you some of the parts of it which will be helpful in understanding the basic idea of functions. That why we are understanding why we are studying pointers. It's not like it's a variable that stores the address of something. No, you have to go through the details. What is actually a pointers? What is how the pointers work internally in our system? You must know the detail. So it is I have already told you in the previous lectures that my course design is my course design basic is that you should understand from depth our topic, nothing left behind. Not like that you understand for sake of scoring score or something, but you are studying for sake of gaining knowledge. So let me just give you some brief idea how this actually works. Okay, so something imagine that I have, or which I have given you some example earlier also, that you write something in this part, and after writing this, imagine this programmable chip where everything is codes are written. So you can see the codes here. You can see the code that something has written here. Codes. Some statement are given, and some of the initialization will also there. This is a program which you write. This program is being converted into process actually. So process, and this process is being divided in many parts actually, and this part is, these are it depend on operating system and which is which algorithm and data structure they are using, but actually you can imagine that as a page table paging. So page table is something like entry of something, mention the entries of something, logs, like mentioning logs, you can understand in naive way. So this is our process. So it's actually being divided into many parts. You can see this first part, second part, and you can see here it is being divided into 6 part here. So it is being divided into 6 part here actually. You can see that first, second, third, 4, 5, 6. Okay, so this process is being divided into number of pages. Don't think like it's actually being divided. It's actually a process of so it is being virtually divided, means not actually, but it is based on algorithms and some running some algorithms. It is being divided. Okay, so you can see that these are the many pages, 6 pages you can see. And now our main memory or physical memory, which is also known as RAM, you already know that. So this RAM will also divided into some frames in actually blocks, or you can say anything different. What actually happening is whenever your process is created, some part of memory being in main memory, some part of being reserved for that program to run, for the process to execute. And in this process actually these are some constant frame time. So actually some pages of the process being loaded into this. You can see that part of this is being loaded, means this is page number 1. You can imagine it. Page number 1 we loading in some memory address. Suppose this is imagine octal 114 something 14. So it is being stored in octal 14 address number. So it doesn't matter, it's actually implementation based. So it is being stored in here. So different RAM, our main memory will contain different pages. Okay, and you can see main memory is also known as virtual memory actually. Why this virtual memory? Because we are not putting all the pages simultaneously at the main memory. Why? Because we didn't know, we may not need it, or some other process are also running it. So for that purpose, some of the pages are also stored in secondary memory, and it is being swapped and bring back to main memory whenever we required. So this is actually this is the actual way how whatever you write, whatever code you write is being converted into binary and then being stored and then being processed according to its needs. So this is only a basic picture. So if you didn't get anything from it, don't worry. but I just giving you to provide you the gist of the topic only. Okay, so how does actually work in a system? So nobody will teach you about this thing in when they taught you pointers in anything. When they will teach pointers, suppose you if you see any other online lecture, they will not tell you this. Most of them will not talk about this part, But these are the basic part to understand the pointers, how actually pointers work, and why we need. So you can see that address. Actually, the main memory has some addresses, some addresses. Suppose binary addresses. So this we have computer. Our operating system already deal with this part. It has some powerful tool to assess this. It has some design algorithm and softwares to assess the address of this. So the question of pointers is user on a user level can assess the address or not. So that's where the pointers come. The addressing addresses used are already exploited by our operating system software. So it will already deal with address by itself. So the question arises that could me and you can use the pointers too and the address too. So that where the concept of pointers come. So now you understand this why I told you this, why make you understand this. This is where the concept of pointers comes. The where the actually pointers understand that we deal with deal with actually addresses. So this is the thing you need to understand. Okay. So now moving on. This is the basic structure of RAM. You can see that this is the RAM. So you can see the chips here, 4 chips. So you can imagine it a 4 GB RAM. So this is the base random access memory actually, and you all know that. So it will store the bit. Now question is one more question. It is actually a digital logic part. Digital logic. I will if I get time I will make a course on that. So it's actually digital logic part, that how the bits are actually being stored in binary in our machine. Now the question arises, so you understand that our program is being converted into machine code, but how this machine code are being stored in a hardware device? So have you ever think about that, how these are stored in our hardware? So basic idea is about gates. You might have from elementary school you have idea about AND gate, NAND gate, AND gate, not gate, NOR gate, and something like that. So these gates are not the end of this part, guys. So AND gate, if you know that what is AND gate, this is our AND gate. It take two input and two input AND gate it is actually. So whenever the input is 0 0, it is 0, and when it is 0 1, it is again 0, it is 1 0, it's 0, and it will be 1 in only in one part. So you can imagine this part as switch, 0 on and off. 0 means off and 1 means on. So this is the basic idea how this actually work. You can see some switches of naive term, some switches are there, and it's been triggered when the bits is set. Set means if the bits is 1, then the switch will be on, and if the bits is 0, the switch will be 0, switch will be off. So in this way the bits are actually being stored. It's a random memory, so it is electronic chips. So it will work in that case in a switch pattern. So now I've told you how the addresses are being stored in a form of switches or gates. So which is not necessary for your class. Actually, which is if you want to know more detail, it is actually flip flops. Okay, flip flop is a basic building block of any bits. It consists of only one bit and it's stored only one bit. 1 or 0. It will store only one bit. Okay, one bit. So this is the case here. So you understand this. This is the RAM, and this is where our addresses are being stored. So now moving on, let me give you the zooming structure of RAM. Okay, so you can see this is one chip of RAM. So actually all the codes are being stored in form of flip flops in basic building blocks, and these are help to process the address here. Okay, so this is the case, guys. Now if you zoom out more, you will see this part in a matrix format. Actually, this is the basic. Now we are going into you are making the granularity more and more, making the simulation more at grain level, multiple granularity, coarse grain. So this is the memory part here. This is, you can see, if you dismantle if you just open up the RAM chip, you will find this. Okay, so if this is considered this part only. Okay, hope you not visible. Suppose this part, let me choose different color. Suppose that I am dealing with this part only. Okay, for one sake, for God, for sake of understanding. It might be anywhere, it will be at somewhere else. So this is the addressing part actually. Addressing means this is a matrix where our addresses are being stored in a bit by bit or byte by byte. So each of this can be system dependent. It can be a 2 byte or it can be a 4 byte, depending on your system. So 2 bytes means 2 into 8, this is 16 bit. So all the things will be stored in 16-bit binary form, means 2 power 15, 2 power 14, 2 power 12, 13, and so on, 2 power 0. So this is the basic bit format here. So any bit can be set or unset, and depending on that, many number and many addressing will form. So actually addressing will form is 2 power 16 minus 1 addresses will be formed. So which is nearly equal to more than 1k. So which is nearly equal to, you can calculate it. So this, in this way, the bits are stored. So each bit will have some binary codes, 1 means 0 1 1, and suppose you write something code here, you write int a. So int a is means the variable a is been declared. So now whenever a variable is declared, it is being space is provided in our RAM actually. So you have already seen your direct structure that how it actually work. Means whenever you write a code, it is converted in a process, and process are converted divided into so many pages, and these pages are being loaded time to time into the RAM. And when they are loaded, they are being stored in allocated in some space, and that the variable which are stored and the variable which are declared within the code are being initialized and being space is provided. Suppose that this so this will be actually at 16-bit converted into 2 bytes. Suppose this system is 2 byte, so this will up 16-bit actually. So 16-bit 16-bit each part, and a variable will stored in this 16 bits only. What will the value of a? So suppose a have value of 64, so it will stored at, you already know this part, okay. So all the part will be 0, and the 2 power 8 bit will be set only, it will be 1, and all other bits will be again 0. So it will be actually 64. So 64 number is stored in binary in this format, okay. So I'm not giving it the actual part or 16-bit, but this is some, you can get some idea from it that. So it is being stored. So so you can see that in RAM how the system is working actually. In RAM, the value of a being stored, and it will have some address. Obviously each part is the part of RAM. So RAM chip, so it will have some address. So suppose this address has seen some binary 001 or something, this address. So whenever operating system have to deal with needs the data of this variable, it will not operate with this variable actually. It is variable has been declared by the users. So it will actually deal with the bits which are set when the variable is been declared in the RAM chip, that is the address of it. So it will deal with it is dealing with the address. So you can see it will look into the address 1001 something, and in this address the value of a is present, which is equal to 64. So in this way, operating system is actually dealing with the address. You can see it, and internally operating system dealing. So how now the question arises: can you also access the address of this variable a? Are we permitted to do that? Yes, we can. And where the concept of pointers come, actually. So pointer will help you to also access its address, which is being accessed by operating system. You can access the same part also. So how interesting this pointer is. So now you can see the power of pointer here. How pointers can be work by using pointer you can deal with address, and which is very important. You might not be getting it right now. You might be thinking, yeah, accessing address is not very big deal. It's not a very cool thing to do, but you will find it very interesting thing. Suppose we are doing now the task operating system. So operating system has access of all the addresses of any variable declared or anything which are stored in its RAM or memory. But as a user, you can also deal with the address, and this is provided by the pointers. So now hope you guys have some basic idea about the pointer till now. Okay, so this is just introductory part, so no big deal if you don't understand this. Okay, just keep it with. Okay, it will be very essential for you. So now moving on. So now let me give you whatever I declare, told you there. This is just a PPT view. So hope you. So let me just explain again. So suppose the variable this is our some snapshot of program, some snaps of program at some time. So two variable are been declared and the third variable been declared. So what happened in the memory part? So in memory part in RAM, which you seen the diagram earlier, that some part will it will choose some random number depend on its implementation and give the space to A and B and C variable. So and they will have some address. So if now you might have some guess it that it will be the case here. So okay, let me show you that. So now how it actually being stored in the memory, you can see the suppose first of all the A variable will declared, so A will be form, A variable form. So suppose A will form first, a space of A will be allocated, then you can see that in some random manner. Okay, not random manner, it's actually implementation bit, but for me and you it is you can understand in a way that is in happened in random manner. So B variable and the C variable will be there. Okay, so in this way addressing will be done and each of them will have some addresses. Okay, suppose in binary anything, and now A and B and C will be stored. Suppose we are performing the arithmetic summation, so A will have some value suppose 5 and B will have some value 10. So the resultant C will have value 15. So 15 will be stored so 5 will be, A will have value 5, so 5 will be stored here, and B have 10, so 10 will be stored here, and the result will be stored in 15. So now how the operating system will deal with that? It will have some program counter. It will take the address of this part, and on reaching this address, suppose we now operating system is the door of the someone house, and by knocking this door, it can get into the house and get the value or not. Understand in this way that it will deal with the address to get the value inside that address also. So and then similar manner it will take the value of A and then store the variable in the address this, and which is being allocated to the value of 15. Okay, so it will done a very nice way in which your operating system works. You can understand it. So now can we do this same thing using a pointers or by ourselves? Okay, so this is our topic. Can we deal with this address and do the job what operating system is already been doing? So you might ask why do we going to do the job that operating system might be asking. So in some program you need to access the address. Okay, in some, I will show you the programs that whenever you can use the pointers. In this program it is very essential to use the pointer. Okay, so you will understand it there. So now moving on. Similar thing can be seen, now let me tell you guys how it's how the pointers work, actually in a naive terminologies. So suppose now we declare a variable A and okay, let me suppose we declare a variable A here. Okay, you can see that it's normal initialization, you already noticed, and this is pointer initialization, actually this part. So this, remember this operator, this is used to deal with address actually. So means for now only, let me not go into terminologies. So now only understand that this is used for declaring a variable which is going to store the address of some variable. So we have to distinguish it from normal variable. Okay, so that's why we use here. Okay, just a notation here which is being designed as we at Genesis design the code C programming. So this is actually a pointer. This is also a basic pointer. So now a variable IPTR being declared, which will with some symbol to distinguish from another variable, because now it's not a variable that is stored some value. It will store actually address. So we have to distinguish this this variable from another variable which stored address, which does not store address. Okay, so that's why the star symbol is being used. And this is a ampersand operator. You can see ampersand, and you already know that this is addressing operator, also known as this will, if you apply with some value, it will give the address of this variable. Okay, this is so much powerful operator. So IPTR means what? The pointer variable, which it is also known as pointer variable. Okay, which is pointer variable. Okay, so it will store the address of some address of some variable. Okay, so now IPTR will contain the address of variable A. So okay, I don't know you are understanding it, but you earlier also how it's work in variable case. So now imagine that there is one variable known as IPTR which is going to store the variable of address of some variable. Okay, this is the basic idea behind the process, and if you understand it there, how the variable is storing the address of some variable, pointer variable storing some address of some variable, the concept of pointer will be very easier to you. Okay, I'm telling you. So now let me show you. So this is the A variable actually. So variable A will have some value, and this is IPTR pointer variable. So understand that variable will store the address of something is not a pointer variable. Okay, just notice and some nothing else. They will have some addresses. So how what will IPTR will store? So your guess is right. You already gone through this part. I've told you. So it will store actually the address of this or not. It will actually store the address of this part. This address it will be stored because this pointer value we declared with this symbol. Then we stored this IPTR value, stored the ampersand and then ampersand is used to give the address. Okay, remember these points. So this will store what? This will store actually the address. So you can see the address. So now you can see that it actually stored the address of some variable. So you can see tell in something that is pointing to the variable A. So IPTR is pointing to variable A. Now you understand the notice on a pointers, which the first diagram that you have seen in the PPT. So and it's that you've seen in the slides. So this is the basic concept of pointers. Now you hope you have some idea about the pointers now, that this is some variable, this is some address which will this variable this is of course this is a variable, and this will also stored in the same memory address of the computer chip, and it will now consist of address of this part. This variable A variable have some address which is being stored by IPTR variable, which is a pointer variable. So in this way the pointers works actually. So in this way now you can do many things with this IPTR value. You can value of, you can write like this value IPTR. You can perform it some another variable, the value of IPTR 2 or something. So you can perform addition, you can do anything. Now you can see that we are now dealing with the address, and we can access the variable using the address part, and using the address we are assessing those value using and then we are performing the operation. So now you can say that this job was done by operating system. Now you can see at a naive user with the use of pointers you can deal with this stuff, that things too which are deal with which were done by operating system. So this is the power of pointer. So this is just a basic lecture, guys. So I will not go into the detail. Okay, so that was all, guys. So this is the basic idea of pointers. So in this lecture I've introduced you the pointer, what is pointer, and why you are studying the pointer, and how it actually work in the internal of system. So hope you have some idea about it. So only the introductory part. I will not go into details, and in the next lecture I will give you some terminology of pointers, and you can see many more lectures, upcoming lectures, some coding example of pointers and many things. So the concept will maintain in your mind. So thanks for watching. See you soon. Take care.